Hello, it's Bill again. And today we're going to study what is motion in your own reference frame in special relativity. So in this first frame, we are looking at the foundational geometry of the universe as a relational network. We have two observers, Alice and Klaatu. Both Alice and Klaatu are pinned at the absolute center of their own unique cosmic holographic horizon. These horizons are not just edges of sight, they are the physical hardware, the 10 to the 69 joules clearance engine that processes and resolves every bit of information in their respective reference frames. The size of these horizons today, 14 billion light-year radius, is a direct result of the universal ledger. Shortly after the Big Bang, 10 to the 122 particles crossed our collective cosmic horizon. Since each particle represents one Planck area on the holographic surface, 10 to the 122 units of area naturally resolve into a sphere with exactly a 14 billion light-year radius. Alice's cosmic horizon functions as a thermodynamic ledger, delta S cosmic plus delta S local equals 0. Now notice Alice's dark energy gradient. Because her cosmic horizon pulls information at the speed of light, the expansion rate is constant, 70 kilometers per second per megaparsecond. She sees Klaatu receding at 0.8 c because he is located 11.2 billion light years away. From Klaatu's perspective, the symmetry is perfect. Alice appears at his 12 or 11.2 billion light year mark, receding at the same rate. At this at-rest state, Alice is perfectly balanced in the center of her gradient. Her cosmic holographic horizon and her dark energy Rindler horizon are one and the same, coincident at the 14 billion light year boundary. There is no offset and borrowed expansion energy yet. This is the universe in its most efficient symmetrical state, clearing exactly 1 light year of space-time per year to maintain the 10 to the 69 joule ledger. Now here you can see that Alice is here, but objects that are right here at 2.8 billion light years away are receding at 0.2 c. And at 5.6 billion light years away, 0.4 c. And same thing over here. Any direction will be pulling away at that value. By moving this focal point, we've moved the focal point from here to here. Alice is accelerated, and by moving this focal point exactly 2.8 billion light years towards Klaatu, Alice has changed how she resolves the space around her. A planet at that 2 billion light year mark, which previously appeared to recede at 0.2 c, now shows a 0 Doppler shift from her perspective. She has effectively phase locked her ledger to that distant coordinate. Notice the immediate consequence. Because Alice is now swimming with the dark energy gradient in the forward direction, an energy deficit is created in that moon-shaped region in front of her. This is the emergence of her dark energy Rindler horizon. To balance the books, the universe projects space from that distant focal point, causing space to flow past Alice at 0.2 c, even though she remains at rest in her own cosmic frame. Whether Alice is accelerating or coasting, the dark energy projection focal point dynamically adjusts to preserve the 10 to the 69 joules clearance energy of her cosmic horizon. She hasn't moved through a container. She has successfully remapped her 14 billion light years space-time to maintain the new velocity. So you can see that Alice is right here. She's still stuck in her reference frame. She's projected her focal point to here, and now you see that space is moving away by Alice at 0.2 c. In this slide, Alice has traded even more inertia energy to shift her dark energy focal point to the 8.4 billion light year mark. At this high-speed gear, Alice still sees Klaatu further ahead at the 11.2 billion light-year coordinate, but because her own projection has moved so far forward, the relative gap is closing. Klaatu now appears with only a 0.2 recessional Doppler shift from her perspective. Notice the dramatic change in the Rindler horizon. So this is Alice's Rindler horizon right here. You can see this is the back of her cosmic horizon right here. And when she's moving forward, her Rindler horizon extends. This is her forward part of her cosmic horizon. Her Rindler horizon extends way past that. So when she's moving, that means less energy is pulling in this direction. So in order to preserve this entire 10 to the 69 joules, space speeds up going back that way. Even though Alice is still pinned at rest with her own cosmic frame, the universe is now moving space past her at a steady 0.6 c. The 10 to the 69 joule clearance mandate remains intact, but the accounting has become much more asymmetric to maintain this velocity. She is surfing toward the limit of her own cosmic horizon, proving that momentum is nothing more than persistence of this geometric effect. In this frame, Alice has reached her craft's top speed of 0.8 c. By shifting her dark energy focal point to the 11.2 billion light-year mark, she has perfectly matched recessional velocities with Klaatu. In this state of total synchronization, she sees Klaatu's local clock tick at the exact same rate as her own. Alice is now deep within her dark energy focal point gradient. Space is rushing past her at 0.8 c, yet she makes zero progress against that focal point. Because Alice is permanently pinned to the center of her own cosmic holographic horizon, she will never actually get closer to Klaatu, regardless of how much space flows by. Look at the horizons. Alice's dark energy Rindler horizon has now become coincident with Klaatu's horizon. This is the ultimate proof that speed or that movement is not a physical travel through a container, but a geometric remapping of horizons. Even at the extreme offset, the 10 to the 69 joule total clearance energy is preserved. The universe continues to clear exactly 1 light year of space-time per year, proving that the conservation of momentum is simply the persistence of this cosmic horizon black hole-like energy constantly pulling space apart. Alice hasn't just moved, she has become a permanent part of the cosmic algorithm. Now in this slide, we see what happens when Alice attempts to push her craft beyond the universal speed limit. She has discovered a fundamental information error, the faster than light problem. Remember, Alice must always be at rest with her own reference frame. She is permanently pinned to the center of her logic. As she tries to accelerate further, her Rindler horizon continues to close in from behind. However, this trailing edge can never cross her cosmic horizon. If she were to go faster than light, she would become causally disconnected from her own projected focal point. She would have no way to communicate the movement of space because the system would be trying to project a state that the hardware hasn't yet calculated. The fastest speed Alice can ever attain is limited by the maximum redshift on her own cosmic horizon, that massive holographic surface that clears just under 1 light year of space per year. The energy required to clear space for faster than light travel is simply greater than the 10 to the 69 joule clearance capacity of the cosmic horizon. The speed of light isn't just a law, it's the hardware limit of the 10 to the 122 Planck area engine. And that is it for our study of movement in special relativity. And check out my other videos to understand more about gravity, dark energy, dark matter, how entropy conserves, how the Big Bang works, and the geometry of the observable universe over time. Have a great day, and remember, gravity is for the masses.